Carbon capture technology, often referred to as carbon capture and storage, CCS, or carbon capture, utilization, and storage, CCUS, is a set of techniques designed to capture carbon dioxide, CO2, emissions produced from the use of fossil fuels in power generation and industrial processes. The primary goal of carbon capture technology is to mitigate the impact of anthropogenic, human-caused, CO2 emissions on the global climate by preventing the release of large amounts of greenhouse gases into the atmosphere. Key components of carbon capture technology include capture. The first step involves capturing CO2 emissions produced during the combustion of fossil fuels in power plants or industrial facilities. There are various capture technologies, including post-combustion capture, pre-combustion capture, and oxy-fuel combustion. Post-combustion capture involves capturing CO2 from the flue gas produced by the combustion of fossil fuels. This is the most common type of capture technology and can be retrofitted to existing power plants. Pre-combustion capture involves removing CO2 before the combustion process occurs. This is typically applied in integrated gasification combined cycle (IGCC) power plants. Oxy-fuel combustion involves burning fossil fuels in an atmosphere of pure oxygen, resulting in a flue gas composed mainly of CO2 and water vapor, which simplifies the capture process. Transport. Once captured, the CO2 needs to be transported from the capture site to a storage site. Transportation methods include pipelines, ships, or trucks. Storage. The captured CO2 is then stored in geological formations, such as depleted oil and gas reservoirs, deep saline aquifers, or other underground formations. The goal is to securely and permanently store the CO2 to prevent its release into the atmosphere. Utilization. CCU. Some carbon capture projects focus on utilizing the captured CO2 instead of storing it. This can involve converting CO2 into valuable products, such as chemicals, fuels, or building materials. This approach is known as carbon capture and utilization, CCU, and is seen as a way to offset the costs of capture and storage. Carbon capture technology is considered a crucial tool in the global efforts to mitigate climate change by reducing greenhouse gas emissions. It is particularly relevant in industries where decarbonization is challenging and where fossil fuels are expected to remain in use for the foreseeable future. Despite its potential, carbon capture technology faces challenges, including high costs, energy requirements for capture processes, and concerns about the long-term storage of captured CO2. Research and development efforts continue to improve the efficiency and feasibility of carbon capture technologies as part of a broader strategy to transition to a low-carbon and sustainable energy future.